Okay,
So we are
guys.
live, right?
Yes, we are live now. Bismillah
Okay.
Rahman Rahim. How are you, everybody? Welcome again to Riyadh Java User Group. Here in Riyadh Java User Group, we organize all the Java related topics, sessions, talks. We welcome everybody, all the speakers around the world to join us and to deliver their experience and their also talks and sessions. Today we have a special guest. Thank you, Akin, for being with us.
Sure. I'm honored to be here. Thanks for inviting me.
Thank you so much. So let's give a little bit introduction about Akin, the speaker. He is a very common and worldwide speaker. He has a very great experience in terms of architecture, software, and clean code and modeling. So we are really honored to have Akin in our Riyadh Java user group, and also he is he has some courses on Udemy platform, so please do check them up. So before we give you the stage, Akin, we would like from the audience, everybody in the audience, please to communicate and collaborate with us here. If you have any
Definitely.
questions, please drop them in the post in the comments below, and we will try to ask the speaker later on.
Yeah, anytime.
So, yeah, good luck, Mr. Akin. The stage is yours. Okay, salam alaikum.
Okay. Selamünaleyküm, brothers and sisters in Saudi Arabia. Okay, so I'm gonna talk about the topic of my talk is better modeling techniques that records that came with Java 16, I guess, creates for us. Okay, so I'm gonna go through my slides, and sometimes I'm going to present you with some models to better understand what is going on. All right, let's come back to my slide. And yeah, I'm based in Turkey. I used to be I used to start working on Java in the United States. I am one of a few people over the world who has been certified for Java 1.1. Anybody remembers Java 1.1? Yeah, I start working with C++ and then switched to Java when it came. All right, since then I keep using Java from the beginning. Okay. Yes, yeah, you can ask anytime questions. Just break me and stop me and ask questions. Okay. So my emails are right here, and we can get connected on LinkedIn too. So I am really happy to be here and to get connected with you. I'll be more than happy, right? Okay. So my topic is some problems of abstraction that we create for our domain, and how functional thinking, especially immutability and records are immutable stuff, immutable types of the Java, new types actually. Okay, how records help us to fix them. Okay, all right, let's start with abstraction. So I have a question. I have a very weird code. It is a code from a real project. I come across with this one-liner. You see, this is only one line of code. Okay, it ends right here. Okay, it is so short that nobody could easily comprehend it, what it does. Okay, but that it is not makeup. Okay, it is not created by me. Just to give you an example, I just came across this one-liner in a real project. So what is wrong with this? What do you think about it? You can say that, oh, there are some code duplication even in one statement. You see, you are calling this method and then this method again. Why? Because we don't use any, we cannot use, local variables in one statement. So we don't have any blog or something like that. So all code duplication. What else? Okay, it doesn't use space well, causing unreadable code. It looks like they are paying like dollars for every line. That's stupid, right? That's really something stupid. Okay, and the third one, using a ternary operator. This one that I don't like, and I know that some languages like Go doesn't include that. Why? It is confusing. I mean, the language Go doesn't have any ternary operator. Okay, so Java has, as C++ has. So this ternary operator used 3 times. Have you ever, took Oracle JCP exams? They only ask 2 ternary operator in just 1 line. Okay, that's much harder than a question in Oracle JCP exam. So that's stupid. Okay, so these are the main problems of this line, actually, that makes it really hard to comprehend and use it. Okay, but what I'm trying to say and show you is that the problem is bigger than this. Okay, when I saw this one-liner, okay, I came with the answer, which is better one, which is right here, and that's a much better one than this one. It does the same thing. Okay, I am using local variables, so I am reusing variables. I am not duplicating code. I am using the space very very intelligibly, so that people could really easily understand what is going on. There are 4 cases here. Okay, it depends on the result, depends on whether you get the information from web service or from the form submitted through the web, or it is a Turkish citizen or not. There are only 4 cases. But when you look at this one-liner, you don't see it, right? And the main problem are not these. Okay, yes, these are problems, but the main problem is about the level of abstraction. Okay, so the level of the abstraction must fit the problem. So one line, a statement, is an abstraction of programming languages, definitely. Okay, but the problem with statement is that it is not fit for this task, trying to figure out whether it is a Turkish citizen or not, whether that information comes through a web service or a web submission, web request. Okay, so it requires a better abstraction. Better abstraction can be a method, you see, and we are not repeating the same code, so we are reusing local variables, and even this line can be scattered into different places on the same system. Okay, but if you have a method, you keep calling it. So method is the most basic block to achieve reusability and to localize the complexity. This is not localizing complexity. That's why it's not even abstraction in terms of hiding the complexity. It doesn't hide. The complexity is so obvious, so we should understand its complexity, solve its complexity to really understand what is going on in just one liner. Okay, this is just one example. I am trying to say that the level of the abstraction should fit the level of the problem. Otherwise, we're gonna go into problems like hard to understand. The code will be really hard to understand. Code would be like scattered. The same piece of code would be on many places in the same system. So when you change one, you need to keep track of other places to change the same code again and again. That's maintenance problem. That's very common problem for software systems. They mostly due to abstraction problems. Okay. Any questions so far? Okay. So what I call it insufficient abstraction. Yeah, statement is an abstraction, but it is not a good fit for this task. So it is abstracting something, but not at the good level to hide the complexity of this task. Okay, so the right level of abstraction would be at least a method for this task. All right. I guess we don't have any question. And think about this way. This is more like philosophical approach to that problem, abstraction problem. Okay, I am claiming that one-liner is wrong abstraction because it does not have a name. Okay, most of the abstractions like methods, variables, or the types like enumerations or classes, or sometimes blocks in languages or in Java will definitely have a name. Having a name makes talking about the issue or talking about the code possible. So I'm asking you, let's say that one-liner is in a method called process card. So you are trying to discuss something related to that one-liner with your colleague. How can you discuss, let's say, a bug that exists in that one-liner with let's say your colleague Muaz? So how can you talk about this? I can talk about this way maybe. Hey Muaz, there is a huge one-liner in method process card. It's between like line 62, line 66. Can you please fix it? Do you think it is a healthy talk? Do you think it is like trying to talk or trying? I mean, it is not like being able to talk. It is like being unable to talk. How can I talk about something that doesn't have a name? That's about philosophy of language. Okay, our understanding, our let's say interaction with reality always start with a name. If something doesn't have a name, that something even doesn't exist. So name is the most basic, okay, actually first abstraction that our mind creates. That's why in holy books, even in Quran or Torah, okay, God says that I taught Prophet Adam names. So having a name is the first thing to create something. Same thing true for a piece of code too. If a piece of code doesn't have a name, you cannot talk about it. If you cannot talk about it, okay, you will definitely have difficulty to identify it, and you will try to identify that piece of code using maybe line numbers, which is of course problem. Okay, you can change line numbers too. You can reformat it. Okay, so the main problem with this one-liner, even though it does an atomic thing, maybe it should be reused in somewhere else in the same system. It doesn't have a name, so we cannot talk about it. Okay, so that's I mean, if you really understand what I mean, I am saying that if you want to talk about a piece of code, okay, it should have a name. It's going to either be a variable or a method or a type or a block with a name so that you can identify it. You can say that, you don't say that like third block in the main in a method. Instead, give a name to a block, make it a method maybe, or keep it like there is like method inside method in C#. That's a good technique. I mean, we don't have in Java, we cannot define methods inside methods, but you can do it in C#, which is a good technique that allows us to give a name into a specific block of code as if it's a method inside a method. We can achieve the same thing using blocks with a name, which is very rare. I don't see this kind of code. So we can create a block here and give a name, let's say problem. Whenever you say problem, everybody understands this piece of code. But if it like calling this task from different places in the system, you will definitely make it a method so that it can be called. Okay, so that's the like more philosophical problems behind those kinds of wrong abstractions. But any questions? Is it worth making the code longer to make it clear? What do you think? Okay, that is a good question. And I guess Brother Moaz, and he says that making a piece of code longer make it clear. That's a discussion. I used to discuss it at the beginning of my clean code course. Okay, which one deserves more attention? Okay, length or understandability. Okay, we mostly think that the shorter the code, more understandable it is, but it is not the case. Okay, for this case, especially for, let's say, for this case, it is so short that it is shorter than it should be. Okay, so we are sacrificing the understandability here for the sake of shortness. So if there is a conflict between the length and understandability, we should definitely pay attention to understandability and create longer code. Is this the answer? And do you think this is clear? Yeah, that's a good question. Okay, sure. Let me just come back to my slide. Okay. Yes. How about that? What's wrong with it? We have an employee. It's a class, and we have a bunch of fields that describe the employee. Think about its abstraction level. I claim that for like business rich domains, okay, this will create the same problem that we have here. Okay, what is that? We cannot, with this kind of abstraction, we cannot localize the complexity, and we cannot talk about the subparts of this this abstraction. Let me show you how. How about now? You see, we have an ID here, and we have some like name information, and we have address here. Now, in Turkish, when you count like zip code, city, neighborhood, street, building, everybody definitely would understand that you are talking about an address. They will object you. Why are you counting all this instead of saying just address? That's an address, right? How about this? These two pieces of like home phone or cell phone constitute another subtype called phone information or just phone, right? How about this? This is about employment. How about that? That's about compensation, different portions that constitute all make up the compensation of the employee, right? So we can see the different portions of the employee, and we can create subparts or subtypes for those like name, address, phone info, whatever, so that we can name them. Okay, because your customer is talking about the different portions of a name. Maybe the customer is talking about some functionality of the name. Maybe he's talking about your customer, or she's talking about how to, let's say, format an address using different languages or using different styles, different formats. They are all functionality specifically related to address. If you have an employee, what is the correct place to put those functionality about the address? You can tell me that we can put it into here, like format address. But the problem is that different classes, different types, like user or company, might have same fields too. So are you gonna keep like copying or formatting functionality into different types? Definitely not. That's the first problem. You cannot localize the complexity if you have such like coarse-grained object. So you are missing some abstractions. You have insufficient abstraction. You are not abstracting away what is related to address. So there is no place to put the functionality related to address. Most of the time, people create a class like address util, and put like static methods over the on the address util. So we keep having zillions of util classes. That's very common anti-pattern. So what is the cause behind having those stupid static methods and classes with lots of static methods? Insufficient abstraction. Instead of abstracting away this address into a different type and putting all functionality into that class, it is a type. It might be a class or whatever else. It is not specific to Java. That's a generic problem for objects, right? So it might be struct, it might be a class, whatever the programming language uses, right? And put those functionality into that type so that you can localize the complexity, and other parts of the software will just make calls to get the service for that type. Okay, so that's the same problem as that one-liner in different contexts. Okay, let's clear this stuff and then proceed. How about having like an employee with the type ID, name, address, phone info, employment, compensation, family info, all smaller subtypes. You see, that's the composite object which has different sub-objects, and each object would have its own state and functionality, like format, let's say, address, or here validate ID. Before creating an ID, or when you call the constructor of an ID, it will call let's say, a private static method that will check the validity of the ID, and it's going to return you, let's say, an exception, or return true or false, so that you will definitely you will understand if that ID is suitable for the domain. Okay, how about compensation? You can create specific methods, behavior specific to compensation, put it here. So that's about, there are actually two benefits that we had when we had that one-liner. Okay, the key is break up the big picture into smaller parts for better modeling. That's a good understanding. That's a good summary. Okay, thanks, Moss. All right, let's move. Any questions so far? we call those objects, they are domain objects, we call them entities. So these are entities. So far, I am claiming that if you create smaller entities and make the bigger ones composed of the smaller ones, you can localize the complexity. You can reuse that complexity without knowing what is going on, because it is an abstraction. Okay, and moreover, you will have many names. Okay, you see, remember, naming is the most basic abstraction. If you don't have a name, something doesn't exist. That might be stupid sentence. I am claiming that as I love philosophy. I especially love philosophy of language. I am saying that for something, some entity, it is not related to software. In our reality, if something comes to our attention, it starts with a name. First, we give it a name and then try to understand its properties, its behavior. What color is this, or what is its relation to this? Okay, but everything starts with naming. If you don't have a name, it doesn't exist. You see, the same thing is true here. If you don't have a name, let's say to this part of the code, you cannot talk about it. How are you going to talk about it? You keep talking that, oh, Tolga, there is first name, middle name, last name in employee. Do you think it is talking? It is not being able to talk. It is being unable to talk. Okay? My mom don't talk this way. Okay? It says, he says or she says, okay, this is a name, right? This is the whole name. Maybe there is a family name, first name, middle name, but there is a succinct, there is a short name for all those different parts of naming. Same thing is true for this. This is address. Okay, we can create the same subtypes and give them name so that we can have a better modeling, so that we don't go into that insufficient abstraction problem. It is a really big problem. When you have insufficient abstraction, you cannot talk about your code, and you cannot keep the complexity in one place, in one safe place, and you cannot abstract it. Okay, it will be definitely scattered into different places of the of your system. So it's gonna be unmaintainable system, right? Uncomprehensible and unmaintainable system, which are the biggest two problems for today's software engineering, right? Let's continue. Okay. Yes, and others, of course. And which one is better? Okay. Now, Muaz, you can ask me, this one is better. Under which circumstances we can think that this one is better? If you don't have any business functionality or business logic related to subparts of the system, that means you have only CRUD operations. You are creating, reading, updating, and deleting objects. You don't have any business logic. You just create employee, present it to user. User will definitely change something. Let's say update the password or update the, let's say, home phone number, and then we submit it back to database so that we can update the entity at the database. Okay, so if it is only CRUD, you don't have to have rich domains. Okay, so it pays off having such a smaller abstractions with localized behavior when you have really rich domain objects, rich domain behavior. So we already talk about this naming. if you want to talk about a piece of code, you must give it a name. It starts with a name, okay? So that you can discuss about that portion of the code. That's you remember ubiquitous language? Remember this phrase, ubiquitous language? That is the language common to everybody in a project, starting from the customers up to back to developers or front-end developers, back-end developers, DevOps guys. Everybody uses the same language, and the nouns of that ubiquitous language is stamped from the language of the customer. Ubiquitous language. That means if your customer keeps talking about address instead of state, zip code, or some other parts, you should have the same abstractions in your domain. That's what domain-driven design actually taught us, and it says that that's part of the those names are part of the ubiquitous language. Everybody understand what it means when I say ID or address or compensation. Okay, and complexity. We already talked about this too. We are keeping the complexity local to those tiny objects. Let's say to format the address, default formatting. You might have a formatting for a pattern. Give the pattern and get the string object that's applied that pattern, right? Or a locate, like you might have like there might be different styles of printing or representing an address in Turkish or in Arabic, from left to right, from right to left, okay, or English or German, okay. So it is all about the requirements of the system, right? Okay, let's move on then. Any questions so far? Yes. So in order to have a rich domain model, you should have more names. I mean, more abstractions. Okay, and I create the. Let's say I'll show you a piece of code. If you want, I can send you that piece of code as a project so that you can go into the details of the code. It is not that detailed, but this is the first version of employee. Okay, bunch of fields all together. Okay. It is an employee, and right here I am an employee, but it has different objects, like smaller objects, ID, address. And when you go to address, you will see there is a format. Those are all dummy code. Okay, so it doesn't matter what I do inside the code, but I am trying to present you that you can localize the complexity specific to address inside the address object. Okay, like, okay, any questions so far? Let's move on then. If we want to, I saw several projects. Even address even address is not a good abstraction. Is not like sufficient abstraction. I saw some projects which had like zip code as a part of the address, or city, or like neighborhood or district as a subtype. Why they are creating this kind of smaller objects, object inside objects inside objects, just to be able to reflect the same ubiquitous language in the code. That's it. Okay, they are creating smaller objects that's just to represent the zip code, let's say, to localize the behavioral complexity related to zip code inside that type. That's quite understandable. Okay. All right. So as your domain becomes richer, you can localize complexity specific to those tiny abstractions. All right. And yeah, we talk about this CRUD operations too. So if you only need, CRUD operations, you don't have to maybe create those smaller, tiny objects with lots of setters and getters. You don't need to have more and more setters and getters, right? You just create one huge object and that's it. Several huge SQL queries, that's it, right? So I'm talking about almost logic-free objects. Okay, so far we all talk about object-oriented programming or object-oriented modeling. We all talk about objects, but the title says that where OOP meets FP. So where is FP? Where is functional programming? Okay, that's the second part, and I hope that it's going to be shorter than the first part. Okay, notice that you can notice the substantial differences between different entities. These are all entities, right? These are all the names that are told by the customers, right? She is talking about employee and she's talking about salary info as part of the employee or employment info. Let's say part of employment info, he is talking about a department or employment level or phone info. So what are those differences between, let's say, an employee and some parts of the employee, like address? Okay. So first substantial difference is the fact that the composite objects, employee or customer, okay, we have those composite objects, but we notice that if we don't have a composite object, we don't have its part too. So in order to have an address object as an object, in order to create a salary info, we must have an employee object. The life cycle of those tiny objects totally depend on their composite object. If we don't have an employee, we don't have an address. Okay. In order to have an address object, we should first create an employee object and then create address object and pass that object into employee. Okay. If we delete that employee object, if the employee object goes out of scope, like in the program, we should that the reference for address object should go out of scope too. It shouldn't be reachable, right? Because it doesn't make sense if you don't have an employee object still having an address. So whose address is this? Or whose salary information is this? That's the question. Okay. So if you don't have an employee object, you don't have its subparts too. So it is about existence or life cycle of the object. The first difference is about the life cycle. Okay. The second one about IDs. Most of the time, we should definitely have an ID for employee like TCKN in Turkey, okay, or social security number in United States, whatever in like ID number, whatever it is in Saudi Arabia. Okay, it is totally sensible to imagine that an employee would have an ID. How about address? Most of the time, especially in this case, having an idea for an address doesn't make sense. Okay, or having an idea for salary information doesn't make any sense. Okay, what makes sense is the relationship between salary info and employee. So employee behaves like an ID of salary info because the employee is the owner of the relationship. All right, we use owner keyword in terms of JPA or database persistence. Like I'm not going into details of persistence, but what I'm trying to say, if you don't persist this, you don't have to persist all these subparts, right? That's sensible, that's understandable. Okay, so the other difference, substantial difference, is about identifying the object. How are you going to identify an employee with its ID? How are you going to identify an address? through using the set of fields, right? That's the third one. Let's come over here. As a result of difference in ID, composite entities can be compared only by their IDs. You can compare me with brother Muaz using our IDs, right? If they are the same, we are the same person. If they are different, if my ID is different than Muaz's ID, okay, that means we are different people. But for the address and salary info, they don't have an ID. So how, if you have two different addresses, okay, how are you going to compare them? Using all fields, okay, because they don't have an ID, right? So that's almost always, we use all fields of those smaller objects to make sure that two different address objects are the same or not, okay? So what I'm trying to say is that the drastic difference in terms of those three aspects make them the candidate to, let's say, to model different things in our domain model, right? Any questions so far? Okay, domain-driven design, DDD, has taught us that those smaller entities that don't have their IDs, they don't have their own independent life cycle, behave like a value in the disguise of object. They look like an object, but the totality of its states represent just a unique value. Okay, so it is like an integer. Okay, we pass an integer, or let's say we have like int I equals to 5. Then I pass I somewhere. Actually, I am passing that value because I, as a primitive, represent a value. So it is hard to think that an object represents a value. That's what we call value semantics. We tend to think in terms of reference semantics in Java or in some other languages. But the problem with reference semantics is that it is hard to model using those classes in Java or let's say C#. Okay, it's hard to think in terms of those tiny objects that reflect those properties. Okay, so what is the solution of this? Okay, we are coming to that point too, and the other you can really you can really see here that the state of the address, state of the salary, let's say phone info, all are immutable. You don't change the state of an address, okay? But you can ask me what happens when a user is moved, let's say, from Riyadh to Istanbul. So what am I gonna do? Okay, when he is residing in Riyadh, okay, it has an address that shows that it is in Riyadh. Okay, when he moves to Istanbul, I'm going to create a new address object. I'm not going to change the state of the existing address object. I'm going to create a new object in Istanbul and then set it to employee. So employee is not immutable. The state of the employee can be changed, but the state of the address, state of the salary, probably state of the phone info, they are all immutable. So the main difference, okay, in the main substantial difference among those different kinds of entities are boil down to actually immutability. If we have any immutable state or mutable state, okay, having those IDs or like comparing two different objects, either using ID or some like comparing each fields, okay, they all boil down to immutability or mutability. Okay, if we have a mutable object, that's entity that we have that reflects the reference semantic. Okay, we have an object, we pass the reference of that object everywhere in the system. So anybody changes the object through one reference, all other places will definitely see the effect of that change. Because there is only one object, but lots of references. But here we have a value that looks like an object. It is an object. It is an object of a class. But all fields, let's say, immutable, and you don't have any setters. You only have constructor set the state of that object into a specific state, and that's it. Yeah, you can put business logic there unless they don't change the state of that object. So it is all immutable, right? Okay. So we are trying to differentiate between mutable and immutable objects. So what is about the records of Java? Yes, records of Java are a perfect fit for the value objects of our model. So let's talk about records just in a few minutes and try to understand how we can use records in our rich model. Okay, so record classes, and record is a contextual keyword. It's the keyword, but it's not like an int or for. Okay, it's the contextual keyword. It is a keyword in certain circumstances. For other parts of the code, you can use the word record as an identifier without any problem. It's called contextual keywords. Okay, it's a new thing that I believe came with Java 13 or 14, something like that. Okay, so it has been introduced as a preview feature in Java 14, and then it becomes part of the Java with Java 16. If you are using Java 17 as a LTS, you can definitely use records into your model. Okay, so record is a specific type of class with some restrictions. Records are immutable classes, and they provide a succinct way of declaration. And there is a typo here, and there is a really small, very very good declaration. Actually, we can use. I mean, you don't have to write lots of code. It just produces the code. I'm going to show you just in a minute. So programming languages become more and more functional. That's not only true for Java, but that's true for C++ and C# too. As far as I know, C# brought the records almost at the same time of Java, because there is an obvious need to be able to emphasize the immutability in the as a type of entity, right? So records are perfect fit for the value objects in our models. And the good thing for records, when you have a record declared like this, you are listing the components. They are called components by a Java language specification. It is translated into this code. It is a final class. You cannot extend it. Okay. All fields are final. You cannot declare any other field inside rectangle other than those that you declare when you declare a record. Okay. And it creates getters for you, like in the fashion of domain-driven design, like not get length, but length, but width, okay, which is better in naming. And it will definitely create for you all equals hash code to string method. And some people claim that that's the only benefit of having a record. They keep saying that, oh, there is a record, there is a new type called record. Instead of typing lots of stuff, you just create record. That's not the point. The point is that all state of a record object is immutable, and that makes a lot of difference, having a mutable or immutable object. Okay. And I am talking about some details, and JLS definition of the record is a simple aggregate of values. and that's a value too. That's another value. Aggregate of value behaves like a value altogether, but that's not atomic. Okay, so I already talked about this public assessor method. State of the record is always reachable. You cannot hide it. And you will definitely have a canonical constructor that receives arguments for the component. All those methods are implemented based on that immutability of the component of the object, and they are final. They cannot be abstract, sealed or instant, whatever. Okay, I mean, yeah, you cannot even redeclare the fields. It's all compile time errors. Okay, and that's understandable. You can add new constructors too. You cannot add new methods other than those getters. You can add static methods into records. What I'm trying to say is that you can use records of Java in order to create those value objects and add business logic, business behavior into those records. In terms of business logic, it behaves like a regular class as long as you don't change the state, because state is all final. Okay, and you can use like carrier of data. There are some types in other languages, like as far as I know, data classes in Kotlin. They are like a Kotlin way of having records, right? And you can use records or carrier of data like DTOs. But what I'm trying to say is that the role of records is much more than using them just DTOs. Okay. All right. So we can have, let's say, a class for employee, but a record for employment info, ID for a record for ID or record for address. You see all getters here, and I just put there a method, business method called, let's say, format, or pass a string, a TP, and try to get if that address is specific in a specific city. These are all business behavior, right? But the employee is a class. The problem with this is that that's the output of IntelliJ UML diagram, and it doesn't show the relation dependency between records. Actually, employment info has an instance of department, has an instance of employment level. So it should be something like this in terms of UML. Okay. Anyway, it doesn't matter much, right? So let's talk about the opportunity. Let's wrap up what I mean so far. I just talked about the insufficient abstraction, how we can have like better abstractions through naming and localizing complexity. And then I talk about the records. Let's move them together to meet where object-oriented programming and functional programming meet. Okay. So records are neither a replacement for Lombok. That's a common question. Or we have records, we don't have to use Lombok. I mean, I never use Lombok. I hate Lombok. The problem, you see, keep writing all setters and getters instead of writing setters and getters. Use Lombok. That's it. That's a really big problem. Lombok, I mean, does not allow our mind to think in terms of business logic. Okay, it pushes us to think in terms of setters and getters, which is an anti-pattern to create anemic domain objects with lots of setters and getters, which is created automatically by Lombok. And where is the business logic? Business logic is accumulated into one big cookie monster like service objects. So when you change something, lots of places should change. We are not localizing the complexity. Okay, So I don't like Lombok. So records are not alternative for Lombok. If you see it that way, you are missing the point. Records open lots of opportunities. The first one is value semantic. The second one, it allows us create better modularity. Okay. And third one, it allows us to use more names. Okay, because we are creating like tiny, smaller objects, make them immutable to better model our model, to make it our model safer in terms of changes. Okay, let's move. What I mean by value semantics, that is from Wiki C2. An object has value semantics when it can be treated as a single value. You know, when you have a record, and that represents the value semantic, meaning that those three string objects, okay, represent just one value, like an atomic value. Okay, so I'll give an example here. You see that is a very well-known example. This is from martinfowlers.com. He is talking about this problem in his book too. The date looks like a value. That's the design problem of Java. Date has been with us from the, I guess, first version of Java 1.0. Okay. Problem with date is that it looks like a value. You see, when you create a date object, it looks like it represents only an immutable value that's fixed for Tuesday, 1st of November, 2016. It looks like a value, but it doesn't. That's the design problem of Java's date, and the problem with the date class. Okay, it's been fixed with the new Java, new date and time API that came with Java 8. Remember, what is the problem with this? We create an object, it looks like a value, but it is not a value. Why? Values are immutable, but date object is mutable. It looks like I am retiring on the first day of November. Okay, my friend told me that, hey, we're gonna have a party, but problem is that party time can be Tuesday, and then I just passed them the retirement date, the reference to that. Let's say another class or another method that would organize a party, right? And here my friend noticed that the 1st of November, which is my retirement day, is Tuesday. You cannot have a party on Tuesday. Let's move to Saturday. So it is changing the day from the 1st of November to the 5th of November, meaning that I must work 3 more days. That's problem. It looks like a value, but it is mutable. Remember, how can we fix this? We can fix this in different ways. We just don't give the reference, but make a copy of that reference, give that copy, so that once the object that is referenced by the copy is changed, my object doesn't change. Okay, my object is safe, right? Or make this immutable, like use new date and time API or Java 8. Remember, all objects like period, duration, clock, or local time, they are all final. They are all final. You cannot change them. Why? Because they represent values in time or in date. Right? That's the correct way of representing date and time values in Java. Okay, so you can make defensive copies, give away the other copy, or you can use immutable objects. There are methods in Java util.collections to create immutable objects, or use new time, date and time API of Java. They are all immutable objects. So that is the problem of not differentiating reference semantic from value semantic. Okay, what I am saying, you understand, right? If we use like records, that means we are enforcing value semantics, so we don't have such problems. Okay, and the second one, modularity. It's so obvious. If you have like smaller objects, we can reuse them in different portions of the system. We can localize the complexity into those smaller portions so that we can pinpoint any problem with just a name. We can say that, oh, there is a problem with formatting the address. You see, you don't have to say that line of the code or that package. You are just talking just like your customer, right? That's what domain-driven design call ubiquitous language, common language, right? And it increases the cohesion of the system. Cohesion means that togetherness of the functionality, related functionality and related data should be in one place. It should be hidden from the rest of the system. This is the main, actually, this is what's called encapsulation, right? So strong cohesive systems can be achieved by creating tiny, little, and many objects. If they are records, your code will be much safer because of immutability. And how about this? Have you ever heard this primitive obsession? That's primitive obsession, even though string is not primitive, but it looked like string looks like primitive, right? Even though they are not, they are objects, of course. But that primitive obsession means that you keep together lots of primitives to represent an object. That's not the correct way of extracting complexity. And the other problem with naming, right? You cannot have names, different subparts of that bunch of fields, right? So we talk about this too. The last one, naming. And Wittgenstein, one of the leading philosophers of 20th century that I studied in my master's thesis in philosophy, okay, says that limits of my language mean limits of my word. People think that otherwise. People tend to think that, oh, my word determines my language. That's not the way it is. Mainly, my language determines or creates the word. Meaning that if I don't have any name, I cannot talk about a piece of code. It is as if it doesn't exist. Unless I give a name to a portion of code, I cannot talk about it. So naming is the most important thing in software design. There is a saying about that naming. I'm just gonna tell about it in a minute. So rich ontology. Ontology means like number of existent things. Ontology is part of the philosophy. It is a metaphysics part of the philosophy. It is all about existence. What is existence? Who is existent? Or what is existence? That's what we call ontology. All right. So that's the richer ontology means richer domain, meaning that you would have like name for every piece of code so that you can talk about it and you can localize the complexity. That's what we call modularity, right? So they all support each other. Modularity, naming, and all those good stuff to create better abstractions. There are only two hard things in computer science. Phil Carlton, this is the person who lived, I guess, in 1970s or 80s. It is a computer science guy, and he write the points out that naming and when invalidating cache, okay, are the two most important or toughest problems in computer science. So I'm just gonna add one thing. Main problem with naming is not bad naming, okay? When you look at the clean code books, clean code stuff of Uncle Bob or other clean code codes like Code Complete, they all talk about bad naming. But I am saying that the main problem with naming is not naming at all. Once you don't name anything, you don't have any name, so bad naming is not an issue. If you name something, after that, bad naming can be an issue. Okay, so main issue, main problem, main hardness with naming is like not naming it at all. Okay, so records help us create rich ontology. It allows us name for immutable abstractions. Conclusion. That's the last slide. So thanks for bearing with me. And records increase functional portion of code through immutability that reduce complexity. Records will increase modularity. Records have better naming, right? So thanks listening to me. Any questions? Let me have some water.
Yeah, thank you so much, brother Akın. I think there are no questions so far. I think most of the questions have been answered by you throughout the sessions.
I hope that's the case, because I should suspect that nobody understands anything, so nobody asks questions.
Yes, yes. So I think there are no questions so far. Let's wrap up this amazing session. I would like really by the end of this talk, thank you so much, brother Akın. It was like
Sure.
one of the best really talk I have ever watched. Seriously, it was really amazing, full of
Do you really
information.
mean that? Do you really mean that one?
Yes, seriously, brother. It's really helpful and informative. I specifically, I didn't like go into the details such this talk, explaining the importance of abstraction and naming, especially the naming, and how the OOP will help us, and also with the help of functional programming and the rich model, rich domains, and other things. It's really, really wonderful, and I benefited myself too much.
Yeah, I'm happy
Thank you
to
so
hear
much.
that. Sure. I can send you the slides or code so you can distribute it to
Yeah, sure,
to
sure.
brothers and sisters. Right?
Yeah, sure. Okay. By the end of this session, we also thank all the audience. Thank you so much, our audience, and thank you, the speaker, so much, Akin. Looking forward really to have you more in our talks.
Inshallah.
Inshallah.
Whenever you want. All right?
Okay. Assalamu alaikum.
All right, brothers. Assalamu alaikum.
Salam. Salam.